Hey, Matt Mathersum here with Mathemendous. Thank you so much for joining us and being a part of the program today. We really do appreciate it. Well, today's a very special episode, and before I tell you why, I want to give a big shout out to these guys at Paws Saving Paws. You've heard me speak about these guys, an amazing organization doing phenomenal work, rescuing dogs, be it transportation, adoption, fostering. They do it all, and if you are in a position to help, please reach out to these guys at Paws Saving Paws. You can even head over to my TikTok channel at That's My Dog and get information from there as well. All right, today I said it is a special episode, and the reason it is because I had someone reach out to me earlier in the week and asked if I did any pre-calculus material. They're heading into pre-calculus this school season. I'm assuming it's a high school student, so I'm going to try to accommodate them throughout their school year with some pre-calculus material. And here's how we're going to bridge the gap between algebra and pre-calculus and calculus. I'm going to start off with something that you probably already know. We've got our standard form here. We've got ax plus by equals c, don't we? And over here in our slope-intercept, we've got mx plus b. All right, well, how do we get from here to over here? Well, let's go ahead and show the mechanics. But before I do that, before we get into anything mathematics, I'm going to bring up a picture here. I live in Las Vegas, and these are the Spring Mountain mountain ranges. Spring Mountain mountain ranges around the valley. Look at the very top of the mountain. Don't look at any of the solid components. Just look at the very top of the mountain, and you see that it's definitely not straight. It's up and down. It grooves and wooves and does all sorts of funky things. I want you to start thinking of that as our f of x function. All right, I think we're bringing the picture down now. And the f of x function is going to be noted as this. All right. I'm going to explain, let me get over here. I'm going to explain our f of x function here in a little bit more detail in just a minute. Before I do, though, I'm going to start off again with something that you're familiar with. And let's go ahead and solve the standard and put it into the mx plus b format, the slope-intercept form. And we know how to do that, right? So we want to get the 3y because we're solving for y eventually, aren't we? When we are. So let's go ahead and get the 2x out of the way. I'm going to subtract the 2x from both sides, and that'll alleviate that on the left-hand side, giving us the negative 3y, which is what we wanted. And that's going to be equal to our negative 2x. And we add the positive 12 over here. Well, we're trying to solve for y. So how do we go about doing that? Well, why don't we go ahead and divide everything by 3. That will isolate the y on the left-hand side. The negative 3's cancel out, leaving me the y value. And over here, if I take the negative 2 and divide that by the negative 3, a negative and negative gives me what? Yeah, it gives us a positive. And I'm going to add, or I don't know that I can add yet. Let's say I'm going to divide negative 3, or 12 divided by negative 3 gives us what? Gives us a negative 4. I was almost too quick to put in a positive operator. All right, we'll see. We are now in this format, the mx plus b. And let's just go ahead and graph the mx plus b. And we know that this is what it looks like, right? Mx plus b. And our b is where we start. B is for beginning, right, with 4. And let's take our m, and I'm going to apply it here to the 2. And that's going to tell us how much the y-axis we move up. All right, well, let's just go ahead and graph this out real quick. We're still working with a standard Cartesian plane. We've got our y-axis there. We've got our x values there. And I'm going to make some tick marks here on the y negative territory and the x positive territory. I don't think I have to do anything else tick mark related to any of these other quadrants if memory serves. So we've got our point of origin right here. And we said that we're starting with the negative 4 on the y-axis. So point of origin all the way down to negative 4 is going to put me, what, 1, 2, 3, and 4. My first point is going to be somewhere along the lines of there. Well, we said the n is going to move us up 2, right? I'm at negative 4, I'm going up 2, so I'm now at negative 2. And I'm going over 3. This is just our rise over run, right? That's just our ratio of how much we move up versus how much we move over. So let's go ahead and say that we're somewhere along the lines of here. Now, my lines aren't going to be perfect because an artist, I am not. All right, so let's say that we move up 2 more and we move over 3 more. And I'm just going to eyeball it right here so I can have somewhat of a straight line. Again, an artist, I am not. So that's how it's going to essentially look in a manner of speaking. That's just your y equals x. You grew up that with your whole life doing algebra. All right, well, here's where it's going to get a little bit different. All right? I'm just going to erase this. Let's take our f of x function. And let's set x equal to x squared. Okay, still working on the Cartesian plane. Got our y value here and our x value here. I said that I wanted you to start thinking about f of x as the height and boundaries, and if I didn't, I meant to. So we also want to start thinking about y is equal to f of x, okay? And I'm going to stipulate that here as well. And this is why. No pun intended, I promise. I'm not going to draw any tick marks here because x squared, that function is simply the most basic quadratic formula you can get. It's just a parabola is what that's called. All right, it's a U-shaped. And just a couple of things really quick. I don't want to get too far off the beaten path here. But what we can do with this parabola is I can move it over X number of units. I can move it over to the left, X number of units. I can actually take this and flip it down. Okay, I can flip it over the x-axis. I can flip it over the y-axis. I can even have f of x as equal to negative x squared. And guess what? That's going to produce a mirror image of that. And I can do the same thing with this as well. I can move it up, down, all around. Notations will affect how this translates, shifts, and whatnot. Know that these wings here, just as an example, I can bring these wings down towards the x-axis, or I can bring these wings up towards the x-axis, flattening this whole thing out. Those are just some of the functions that you deal with when dealing with f of x. And to bring it all home, we've got the xy coordinate here, and I know I've said y is going to be a function of x, and here's why. Again, simulating the kind of the mountain range, if you will. From the center of origin, look, this is off the x-axis. This is our f of x function right here. Kind of simulates the top of the mountain range. Our y-axis here and our f of x function here. This is why we say that the y is equal to the f of x function, okay? I want you to just see that visually. Think about it spatially. Well, that's all the time we have for here on Math Madness. I'm your host, Matt Mathersum. I'm going to see you guys soon.